Good afternoon, class. Today I'll be discussing flood management. Here's our outline. Basically, flood is the result of runoff from rainfall in quantities great to be conveyed or confined in the low water channels or upstreams. In one way or another, I know that you've encountered flood. So comment below if where were you during this time when Typhoon Ketsana hit our country. Typhoon Ketsana or Typhoon Yolanda. As far as I remember, I was stuck here in Monumento Station. In a 7-Eleven, I was on my way home. And the flood was outrageous. Being a tropical country, our country, about 20 to 21 typhoons hit our country. So more of a rainy season. Now, flood is a concept of disaster risk under hazard. Well, disaster risk is a complex interplay of several factors, including hazard, vulnerability, and exposure. Hazard is measured by strength and frequency. Let's say the earthquake in Taal is considered a hazard. So the last eruption was way back 1700s. So that is the frequency once per 300 years, 400 years. Storm, tsunamis, those are hazards. Next is your exposure. Exposure is the exposed population density. The people, the property. What kinds of property do we have? Houses, residential buildings, farmlands, and so on. Vulnerability, or the structural and physical social profile, the resistance against natural hazards. So we can say that the elder people or the people with disability are more vulnerable when it comes to hazards. They cannot simply escape flooding, they cannot simply escape earthquakes unless added additional aid. The simple interplay of the factors give us this equation that risk is equivalent to hazard multiplied by population multiplied by your vulnerability. So next semester we will have a disaster science. I think Ma'am CJ will be the one handling it, and let's be excited about it. So 3 views that we'll talk about also is the jurisdiction. The cost of flood mitigation facilities is borne solely by the national government. So funding, primarily your DPWH and MMDA for here in Metro Manila. Local entities must assume maintenance and operation, and approval of local projects is also from the national government. Projects cannot prevent. For the public view, 100%, we cannot prevent floods 100% all the time. It is the responsibility of the engineer to explain the degree of protection intended. A flood warning system is ought to be provided, and finally, risk assessment should always be a calculated one. So as we said earlier, risk is computed. Some flood warning systems are provided by the OST Pag-asa, and so our project before, Project Disaster Risk Exposure Assessment for Mitigation, or Project DREAM, provided an early or flood warning system 6-hour lead time before an actual flood might happen. So I remember the time when I was in the project, all the people don't have classes. All or offices are suspended. Pero kami may pasok, okay? Yun, ganun kakaiba, kaya gabi talaga. What we call flood watch. So we text local authorities, local LGUs, whenever typhoons struck the country. The design flood, standard project flood is about 50% of the probable maximum flood. Project flood is about 50%. So when you design a project or a future flood project, you should provide up to 50% of the probable maximum flood. Now, let's define first what is a floodplain. It's a normally dry land area adjoining rivers, streams, lakes, bays, or oceans that is inundated during flood events. So, in order for us to visualize properly, let's say this river. You can see here on the edges are your floodplains. Okay? So, these are the one inundated every time this river uh, overflows. So flooding concerns are not limited to river and coastal flooding, sometimes urban flood and struck urban areas, urban rural areas. So in order for us to study or analyze or to conduct flood mitigation, we need to educate ourselves when it comes to hydrologic and hydraulic analysis, or basically floodplain management. So some studies include the following: floodplain information studies, evaluation of future land use alternatives, evaluation of flood loss reduction, design studies, operation studies, and your hydraulic and hydrologic analysis through various softwares. So flood mitigation. We can provide flood mitigation through man-made reservoirs. Don't get confused, class. This is also your natural or man-made reservoirs are your dams. So in this case, in this image, we can see the Magat River Integration System. So we reduce peak flow by producing or constructing reservoirs. Confinement of flow with a predetermined channel by levees or flood walls. This is a project in Las Piñas. A 5-meter high flood wall. Kitang-kita nyo naman, no? The walls are very high. I think about 10 to 12 layers of hollow blocks. So reduction, I don't know if you remember this in our first lecture, we reduce the peak stage by increased velocities resulting from channel improvement. So when you improve your channel, you're basically improving the hydraulic capacity of your channel. In this case, the canal cannot maximize its efficiency. We're trapping, or the flow is hindered by your vegetation in your canal. And also your sediments may trap the flow. Diversion of flood waters. So through a flood bypass, which may return the water to the same channel at a point downstream or deliver it to another channel. So we can use diversion of flood waters, or in this case flood walls, for diversion works. Flood proofing of specific properties. So in this case, I get this image in ResearchGate, an article or a journal showing flood proof for a particular house. There's the subgrade basement in order for them to entrap excess water or excess flood. Reduction of flood runoff by land management. Basically, these are your drainage. So drainage are closed conduits in your urban areas. So we land manage by cleaning our drainage or avoid wastage. So disiplina pa rin, no? Discipline in order for us to avoid clogging for our closed conduits, drainage. And as we said earlier, flood warnings, temporary evacuation of flood-threatened areas. So you may check the Bagong Pag-asa, the new website of DOST, and Project NOAA, UP Resiliency Institute. When flood happen or or extreme typhoon events happen. So, floodplain management. So, this is the image of a particular floodplain. So, there's a case, I remember in Cagayan de Oro, no? There's a typhoon that struck the community. And my former professor is actually the brother of Sir Odi, Doc Eugene Herrera. He have said that the floodplain, their analysis was the houses were constructed along the floodplain. So, in this area. So, pag lumakas talagang ulan, they will be caught up by the storm or the flood. So, there must be a clearing distance whenever you are building a community or residential units along the rivers or near the rivers or near coastal areas. There must be a particular clearing distance. I believe that is 100 meters, 100 to 500 meters for coastal areas. Floodplain is management is the operation of an overall program of corrective and preventive measures for reducing flood damage. So some of the following are your management control for your floodplain. So one more aspect of floodplain management involves balancing the economic gain from floodplain development against the resulting increase in flood hazard. So the 100-year flood area can be divided into a floodway and a floodway fringe. On the next image we will show. And finally, floodplain and draination maps are your flood-prone area and flood hazard maps. So one goal to prevent flood hazard. So this is your 100-year flood area. So using the floodway fringe, you are dividing the area. So in our region, Metropolitan Manila, we have several infrastructure projects for our flood control. So they are administered by the Metropolitan Manila Development Authority or MMDA. So ever since 1970s. First, your Napindan Hydraulic Control Structure, which basically connects Napindan and Pasig rivers through a flood control system. Next is your Rosario Weir for Marikina that connects to your Manggahan Floodways and Laguna Lake. And your Manggahan Floodway, the longest, okay? It has design capacity of 2,400 cubic meters with a base width of 260 meters. The images class is from your Google Earth. And finally, your FCOS or Effective Flood Control System, connecting your Pasig, Marikina, and Laguna Lake river basins. Your Metropolitan Manila river basin is composed of 7 highly urbanized rivers. So, as we said, this is from Professor Leongson. If you remember in our lecture 1, I have shared to you that they have proposed constructing a dam in UST. But ever since the beginning, UST or Manila has been the intersection of these several river basins that enable us to be the outlet. Thus, flooding cannot be avoided. The best thing we can do is to mitigate the effects through the steps that we mentioned earlier. So your flood hazard maps are your basically which shows the risk or highlighted areas wherein the risk is higher when it comes to flood happening. So sample of flood hazard maps from Dream website and UP NOAA. The types of floods, as we said earlier, are your riverine and coastal flooding and urban flooding. So, pressing flood hazard issues in our area. So, urban flooding causes watershed deforestation, watershed land use change, improper and unregulated land use, and urban flooding. Basically, all of this causes your urban flood. So, in order for us to counter it, we need behavioral adaptation. Again, discipline for every one of us. Okay? Discipline in watershed management, avoid excess sa mga upstream. In your upstream areas, avoid deforestation. And for the low stream, proper wastage disposal. Monitoring and prediction, floodplain zoning, floodproofing, which I've said earlier, flood-proof structures, and providing flood insurance and public relief funds. So our flood control alternatives will basically, the main objective is for you to alleviate the negative effect consequences of flooding. So whenever you want, class, you may review this lecture slide. Stream when you are comfortable in order for you to learn. So the basic functional relationships required to assess the value of flood damage reduction alternatives are stage damage, stage discharge, and your flood flow frequency relationships. As we can see here, they are directly proportional. So damage is proportionate to the stage or the level of your flood. And as you increase the exceedance frequency, you intend to increase the discharge of your flooding. The impact of measures from your U.S. Army Corps of Engineers. Class, this is the group or the Army Corps of Engineers. They are the group that created the software, the hydrology modeling system, or HMS, and HECRAS river system for your channel cross sections. Flood mitigation infrastructure are the following: reservoirs and your retarding basins to store a portion. These are also class your dams, no? Trade-off between reservoirs located immediately upstream and those located further upstream. The bigger is not always the better. Take note of that. The second criterion for evaluating flood mitigation reservoir is its storage capacity. How can it entrap excess flood or flood discharge? Operation problems. Stream flow forecasts are necessary in planning reservoir operations. Retarding basins are outlet for consists of large spillway. So in this case, we have your laboratory experiment for retarding basins. Your levees and flood walls should be homogeneous in embankments, constructed with flat slopes. So the same structural design as your dam. So sample of these are the following. So these are your diagrams in your fluid mechanics and your statics. And others should be considered items in an overall plan for the stream. Line channels with a vertical sidewalls are not good. Why? Because of friction, okay? And it's not aesthetically beautiful, no? It's not good. You're not maximizing the flow of your water. Straightening should be accomplished with lightning, so the finishing should be nicely and done. Floodway should be used only during floods. Hydraulic design of the diversion works or for a bypass is considerably more complicated than a simple determination of the amount of flow to be diverted. Okay, finally class, this is your hydrologic and hydraulic modeling softwares, your HMS and HECRAS. Class, these are freewares and very user-friendly. You can download it from the website of US Army Corps of Engineers. And meron siyang mga built-in manuals. My thesis advisees have been using this for their studies, and it's very user-friendly. So I hope you can learn it too and be advanced in hydrologic modeling. So that's it for today. I hope you are all well, and God bless you guys, and until next stream.